Thanks, students. The previous video session, you have gone through the table 1.3. There you have learned all the derived quantities and its units. And today we are going to discuss how to measure the length by using different object by using different instruments. Before going to the section, you can go through another table on point 4. Here you can see some basic things about you have to know about the powers of 10 prefix for powers of 10 to the power 1 means water, 10 to the power 1 means deca, 10 to the power 2 means hecto, 10 to the power 3 means kilo, 10 to the power 6 means mega, then giga means 10 to the power 9, tera means 10 to the power 12, peta means 10 to the power 15, hexa means 10 to the power 21. Then zeta means 10 to the power 21, iota means 10 to the power 24. And the another side you can see the symbols. Deca means DA, hecto means H, kilo means K, mega means capital M, giga means capital G, tera means capital T, peta means capital P, hexa means capital E. And you can go through these symbols, take a screenshot and go through this. Then you can see that another value is 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3. So 10 to the power minus 1 means deci, 10 to the power minus 2 means centi, 10 to the power minus 3 means milli, 10 to the power minus 6 means micro, 10 to the power minus 9 means nano, 10 to the power minus 12 means pico, 10 to the power minus 15 means femto, minus 18 atto, 10 to the power minus 21 septo, 10 to the power minus 24 octo. So you have to know just these values and its name, because in physics these powers of 10 is very important, because most of the calculation we are rounding off the numbers, or we will we used to write big numbers by using these powers of 10. In this unit we will study how we will write a big number by using these powers of 10. Okay, so this is the first thing, measurement of small distance using screw gauge and vernier caliper. So in this part you are familiar with this instrument, screw gauge and vernier caliper. In grade 10 you have completed this practical session, and there you have did this practical screw gauge and vernier caliper. And so this is what our basic things for measuring the smallest length. We are using screw gauge and vernier caliper. So here in the textbook you can see I have marked screw gauge means what are the things you need, vernier caliper means what are the things you need. Then this is instrument, the screw gauge and vernier caliper. These two instruments we are using to measure very small distance. So length means not only small distance, sometimes we need to measure larger distance. You know that sometimes from our earth to moon they are measuring the distance also. For that also there are some method using. And you know that sometimes our flight, when aeroplane flies, they will find how much height it is flying from the earth surface, how much height it is, like that, and all measuring by using another method. So in physics for everything there is a solution. So that is what we are going to study. For measuring smallest distance we are using screw gauge and vernier caliper, and for measuring larger distance we are using another method. It is for example if you want to measure the height of a tree or the distance of the moon or planet from the earth, we are using some other method like triangulation method, parallax method, radar method. So these are the three methods we are using to measure very large distance. I will explain what is this. So first thing we can see is how to measure what is screw gauge. So what is the use of the screw gauge? For measuring accurately the dimension of object up to a maximum of about 50 millimeter. You can take a screenshot of this and you can study. Those who don't have the textbook, it is important question. The screw gauge is an instrument used for measuring accurately the dimension of object up to maximum of 50 millimeter. You all know that you all have the practice of measuring by using this screw gauge. We know that suppose we want to measure the thickness of the paper, suppose we want to measure the thickness of the coin, suppose we want to measure the thickness of the wire, for there and all we use this screw gauge instrument. Like that, so dimension of object up to maximum of about 50 millimeter. So up to 50 millimeter object, any object which is up to thickness is up to 50 millimeter, or this length is up to 50 millimeter, we can measure by using this screw gauge. And you know that the least count of the screw gauge is 0.01 millimeter. So you know that least count means the smallest measurement we can write from this instrument is the smallest measurement. That is what least count. For every instrument there is a smallest measurement that we are seeing least count of that instrument, and in this screw gauge least count is 0.01 millimeter. So to measure smallest distance, we are using screw gauge. First thing, what is the use of screw gauge? It is used for measuring accurately the dimension of object up to a maximum of 50 millimeter. And what is its least count? Least count of the screw gauge is 0.01 millimeter. And the next one is Vernier caliper. You can see this diagram of Vernier caliper, screw gauge diagram here. And this is what Vernier caliper. You know that it is a versatile instrument for measuring the dimension of an object, namely diameter of a hole, depth of a hole. Its least count of the Vernier caliper is 0.01 centimeter. Suppose we want to measure like this. Assume that one big pipe. Assume that this is a big pipe. In this pipe, inner diameter is there. Inner diameter means you all know that inside this hole, diameter is there. Outside, around this surface, diameter is there. So external diameter, internal diameter. If you are taking a pipe, we know that internal diameter, inside length of that pipe, and outside external diameter, the both we can measure by using this Vernier caliper. That is what it is saying. It is a versatile instrument. For various purpose we are using. So we can measure the internal diameter as well as the external diameter of a hole also we can measure. Depth we can measure. So if you are taking a small length of a pipe, or you can take this pen cap. So it is very small device. External diameter we can measure, and behind this Vernier caliper you can see a small needle like pointer things that we are using, means we can measure this depth of this hole also. So and its least count, the smallest measurement we can measure from this instrument is 0.01 centimeter. So it is a 3-mark question. They are asking to write about the screw gauge and or Vernier Caliper along with the radar method or parallax method or triangulation method. So you can take a screenshot of this screw gauge, Vernier caliper, and study these two things. So next thing is measurement of largest distance. For measuring larger distance, such as the height of a tree, suppose there is a tree, we want to measure the height of a tree. By seeing the tree, it is not possible to measure the height of a tree. By seeing the moon from our earth, it is difficult to measure the distance of the moon or planet from the earth. So there are some special methods are adopted. That is what a triangulation method, parallax method, and a radar method. Let us see what is this triangulation method. It is an important 3-mark question. You can see here. If you take a screenshot of this triangulation method for the height of an accessible object, you can see this diagram. Let us see this tree. This tree height is AB. The tree height is AB. So AB is equal to H. That is what it is the height of the tree or tower to be measured. Suppose you want to measure the height of a tower or you want to measure the height of a tree. So first thing you have to consider this height of that object is H. That is what here it is taken. AB is equal to H. And let C be the point of observation at distance X from B. So you can assume a point C. Assume that you are standing in front of a BSNL tower or Airtel tower or Jio tower, anywhere you are standing, and you want to measure the height of that tower. So that what you can do is you can stand in front of that tower. Here it is considering at a point C. That is what the point of observation from the distance, from a distance what X from B. So there is an observer. Assume that you are standing here, and now place a range finder at C and measure the angle of elevation. Range finder means it is an instrument. Suppose you are standing, how you can use means you have to stand in one place and you have to hold that instrument and you can measure the place where you are standing and the point at far. Point at far. You want to measure this point A and you are standing at this point C. So you can use a range finder here. Range finder means there is an instrument to measure distance from this point to this point. Now we will get a theta. Now you will get an angle of elevation. So that ACB you can take it as theta. Now assume, listen here. This is what assume that this is the height of a tree. This tree I am taking height AB and this height is H. Okay, so AB is equal to H. It is the height of the tree. Now C is a point. Here I am making one point. C is a point. This is a point of observer where he is standing or she is standing. Assume that you are standing here at the point C at a distance okay, B. At a distance B, you can take this as B, this as A, B, B, okay, this is A. Now you are standing on the position C at a distance x from this tree. Okay. Now here you can use a range finder so that you can measure the distance from this point to this point. So you will get an angle of elevation ACB. So that you can write angle ACB equal to theta. Okay. Now we'll see. Now what you can measure this. This is now you got a right angle triangle like this. You got a triangle. This height is h. This is x. This is b. This is a. And this is what theta. This point is c. Now from this right angle triangle, you can the opposite side of this is theta. This is opposite side. This is adjacent side. So you can measure this theta by using tan theta. So that tan theta, how you can take? The formula tan theta is equal to opposite side by adjacent side. So opposite side is h and adjacent side is x. So tan theta is equal to, you will get h by x. So that you can measure the height of the tree h is equal to, take this x here, cross multiplication. So you will get x tan theta. This is what triangulation method. This is one of the important 3-mark question. Again, I will explain. You can see this height of the tree. You can consider 2 points A, B. Height of this tree is h. And now there is a point of observer. He or she is standing in front of the tree at a point C at a distance x from this tree, from this point B. Now you can see this here at the point C. There is a range finder is placed and measuring this angle of elevation. Range finder means you can measure any distance. You are standing on place and you are focusing on point. That point to you can measure by using range finder instrument and theta. Now angle ACB is equal to theta. Tan theta is equal to, you can take, you see, this is theta. Theta opposite side h. Theta adjacent side is x. So easily you can measure this tree height by using the formula tan theta is equal to opposite side by adjacent side. So tan theta is equal to opposite side is h and adjacent side is x. So that h is equal to, you can write, take this x another side, cross multiplication. If you are doing cross multiplication, x will go here. So h is equal to x tan theta. This is what triangulation. So after this triangulation method, it is you remember that it is one of the important 3-mark question. Triangulation method. Also the screw gauge, vernier caliper. It is important part. You can take a screenshot from your video and you can study this. Now example 1.1. It is very important example. In many exams they asked a 3-mark question problem. This example 1.1. So you have to go through this problem. From a point on the ground, the top of a tree is seen to have an angle of elevation 60 degree. The distance between the tree and a point is 50 meter. Calculate the height of the tree. So this is just an example problem for this triangulation method, but it is important problem. You have to study this problem. You have to learn. Okay, work out this problem today itself. It is just a simple problem only. We know that our formula is h is equal to x tan theta. From a point on the ground, the top of a tree is seen to have an angle of deviation. So angle theta is equal to 60 degree. So theta value we got. We need to find out the height of the tree, and one more information is given is the distance between the tree and the point of observer is 50 meters. So x is equal to 50 meter. So this much information is given. Now you can see that you can write the formula h is equal to x tan theta to find out the height of the tree. So h is equal to 50 into tan 60 degree. So h is equal to 50 into, you can see that behind the textbook tan value is there 1.732. So if you are multiplying, you will get h is equal to 86.6 meter. So very simple problem. It is important 3-mark problem. You have to practice today itself. So my dear students, so again remember that to measure the smaller distance we are using screw gauge and vernier caliper. What is screw gauge? What is screw gauge means? This is the instrument we used. Screw gauge means measuring accurately the dimension of object up to a maximum of about 50 millimeter, and its least count is 0.01 millimeter. Vernier caliper is a versatile instrument for measuring the diameter of hole, depth of hole, and least count is 0.01 centimeter. Then you can use measuring the larger distance. 3 method we are using: triangulation method, parallax method, and radar method. In the triangulation method, I explained here triangulation method. Suppose we want to measure the height of a tree. What we are taking that height as a h, and where we are standing that point as c, and we are using a instrument range finder to find out this angle of elevation theta, so that you see you will get this angle of elevation, whether it is 50 degree or 60 degree or 30 degree, anything. Okay, so that we can use this formula from this right angle the triangle. We are considering a triangle for this. This is what here I did. Considering one right angle triangle, A, B, C, theta, H, X, and we are taking opposite side by adjacent side is tan theta. So tan theta is equal to H by X. Cross multiplying, H is equal to X tan theta. So and based on that triangulation method, there is a problem. Example 1.1. It is very important problem. Previously asked for 3-mark question. So you can just work out this problem. And take these online classes very serious on, because all of you, all the students, those who are watching these videos, just take a notebook. You all have a long size notebook, and take that notebook. You just write all these important questions what we are saying. And today I told about the screw gauge. That is one important question. Vernier caliper and triangulation method, example 1.1. These whole things today itself you take a notebook and note down on it. So revising time, it will be useful for you. So all of you make a physics note and write the things what we are saying. It will help you your studies, and uh, best of luck. Thank you all. Bye bye.